continuation of our tutorial on how optical brighteners work and how we use those in the paper industry. Now this particular video is going to be on actually both the TAPPI and the ISO discussion. So this introductory piece we have right here, once you've watched it once, you can skip that section on the other video. But if you'd like to watch it again, obviously that choice is yours. And the reason is because this information is the same for both TAPPI and ISO. So we're just putting it on both, just in case you don't watch one, you'll at least get it on the other. Just as a quick overview, the purpose of an OBA, an optical brightening agent, is to make white paper brighter or whiter, whichever measurement you make in brightness or whiteness. The goal is to do that, and they accomplish that by, again, absorbing energy in the UV region of the spectrum and emitting that energy over here in the blue region of the spectrum where brightness is measured, but also if you do a whiteness measurement, papers, those formulas are biased to reward blue-white paper. So you still get that bump in whiteness because of that. So it's important that we know how to manage and how to control the dosage of the optical brightener in our processes so that we can manage that properly. One of the problems that you'll get into, and again, when we talk more specifically in the color presentation in relationship to optical brighteners, we'll dive a little bit deeper into this, but as you dose an optical brightener, the law of diminishing returns kicks in. So I could put in a little bit and get a nice bump. I can put a little bit more and I'll get a bump, but that bump it'll start to decrease its value. So I might put in X and I get X in return. I might put in X plus, but I get X plus a little bit less in, and the more I put in, the less movement I get up here on the peak side of things, until at some point actually you oversaturate the system with an optical brightener, and when you do that, then the actual optical brightener begins to combine back together again. And as I mentioned earlier, the optical brightener is a little bit on the yellow side, but anyway, you get this greening effect. So you actually shift the color of the sample towards the green, and so you were starting to overdose your sample at that point. So it is critically important in optimizing your operations that you learn what is the proper dosage of your optical brightener, and that can vary depending upon your fiber source and the other things that are going in to make up your paper. It's important we understand what tools we have for evaluating that, and that's really where we come in with the brightness measurement as the primary tool that most people will use when they're dosing and measuring the effect of an optical brightener. When we talked about brightness, we talked about its original setup was back in the 1930s by the Institute of Paper Chemistry and General Electric at the time, and that unit was set up to evaluate the bleaching process, which we have right here. When ISO developed their brightness method, likewise, it was to monitor the bleaching process, and really we were dealing with at the time, for the most part, naturally occurring colorants in there that we were removing in this process. Once we introduced the optical brightener into the process, we then took that instrument that was developed to do either TAPPI or ISO, and we applied that instrument to that process, even though now it's measuring something that the original instruments weren't designed to do. Fortunately, because we're still talking about the blue region of the spectrum, a TAPPI instrument or an ISO instrument still does a very effective job of managing that. So when we measure brightness in the industry today, that is done under what's called, I'll write this up here, UV or ultraviolet, and you'll often see a small IN for included. So it's UV included. So what that means is that if there is ultraviolet energy in the light source of that instrument, that ultraviolet energy is included in the measurement. So it's going to illuminate the sample, and if there's an optical brightener there and you have UV content in that light source, then that optical brightener is going to fluoresce, and that is going to be included in that brightness or whiteness number. Okay, so it is measured UV included. So to determine the impact of the optical brightener, you have to make a second measurement. And you'll hear the phrase UV excluded, and you'll see an EX with that. And UV excluded means is that what we've done is that you've got a light source, whether it's TAPPI or ISO, you have a light source, and you've got a UV cutoff filter. So we have very specific filters, glass filters that we use that are manufactured in such a way that they cut off certain levels of energy. More often than not, it's a 420 nanometer filter, and what that does is that cuts off light here in the blue region of the spectrum, but its primary purpose is to make sure there is no UV energy that's going to illuminate the sample, so that if there's an optical brightener present there, and now I'm illuminating with this light that has the filter over that incident beam, now that UV energy cannot get to the sample, so that sample can't fluoresce. So it's in a UV excluded environment. And so what happens then is that you will take UV included measurement, UV included, and you will subtract from that the UV excluded value, and that will give you this value called fluorescent component. And it's UV included minus UV excluded, and you get this value called fluorescent component, and that is the effect of the optical brightener. So the optical brightener is increasing my brightness from whatever the UV excluded number is to whatever the UV included number is. So let's just say, for the sake of ease, this was 85 for UV included, and UV excluded was 80. So it would be 85 minus 80, and my fluorescent component was 5. So it means that I'm getting a boost in brightness of 5 points due to the presence of the optical brightener. Okay, so whether we're doing TAPPI brightness or ISO brightness, both methods call for a UV included measurement and then a UV excluded measurement, and the difference between those two are what we call the fluorescent component. Okay, and so it's just UV included minus UVX, the US fluorescent component. Very simple. If there are no optical brighteners in the sheet at all, so there's been no dosage of an optical brightener, UV included, UV excluded will agree, and so the fluorescent component value would be equal to 0. All right, so now what we're going to do is we're going to take and we're going to break that down for TAPPI and ISO. Okay, so we're going to continue this video and talk more specifically about the relationship to TAPPI brightness and OBAs. Okay, so again, really, if you could just summarize the importance of OBA or the role of an OBA is to make your paper brighter or whiter through causing this fluorescence to occur. Okay, so what's interesting with that though is how back in the 1930s when they were developing the original TAPPI method, and again remember that was to look at this bleaching cycle, they really weren't thinking about the future of the chemistry that was going to come into the industry and how optical brighteners would be used so prevalently like they are today to achieve brightness levels. Unfortunately though, but because of the goal of trying to reward a blue-white to the paper, the optical brighteners just fit in perfectly with the bleaching cycle. And looking at that, because if brightness, back from our brightness videos, brightness is just looking at this blue region of the spectrum, and if that's where it's looking, that's where the OBAs are doing their most work. And so as we reward, not as we reward, but as we add optical brightener, and we're seeing that improvement, what we're seeing is an increase in blue reflectance in that sample. So as it turns out, the brightness instrument, even though it wasn't designed to look at optical brighteners, is a perfect instrument for doing the evaluation and the management of an optical brightener. So back in the 1930s, as they were doing the analysis and they were, setting all this up over here using that tungsten lamp, that was what we were doing. And then all of a sudden we start throwing these optical brighteners in there, and now we're having to measure that with this. And so the TAPPI methods group went back and said, okay, we need to look at this a little bit closer to make sure what we've got set up here is the best technology for monitoring the addition of optical brighteners. And so they looked at the UV source that we had, and like we defined earlier, it's a relatively small amount of UV energy, but again, not too different from the typical indoor viewing environment, so it seemed to be like it would be a good match. So they did a study, and sure enough, the outcome of that study said this is certainly an adequate UV energy level for us to define TAPPI brightness around. So they didn't necessarily look at it the same way ISO did, but they looked at this ratio of blue to UV energy. And if we could get that set properly and manage and properly maintain that, then that would in fact allow us to establish a good point for calibration and be able to maintain that over time. So they wrote that into the standards, and then today in our calibration laboratory we maintain that point to make sure that we're not drifting all over the place with the addition of optical brighteners with that. Okay, so when I'm making a measurement on a TAPPI instrument, I've got a lamp, a quartz tungsten halogen lamp that sits here. Then there's a series of lenses that are fitted in here to focus the light source right here at the sample opening. And then there's receiving optics on this side. I make my UV included measurement, and I have my number. And then the instrument will slide into the incident path just right in front of the lamp, a UV cutoff filter. And that cutoff filter is going to eliminate any UV energy from striking the sample. So now it's the same light source, but because I've modified the energy here, the light that gets to the sample doesn't have that UV energy in it, so the optical brighteners can't fluoresce. I've got an instrument set up here. And in that, basically this is what we have. So the optics are setting right here, and the lamp sets right over in here, okay? And we will take a sample, and I will load that sample, and the machine direction of this sample is running this way. So I load that on there. Always use the 1 kilogram weight and an infinite pad when you make measurements. And on this instrument, it's equipped to measure fluorescence, and with the next generation of this and the Test Plus, it also has that fluorescence app that you can get with that allows you to do the exact same thing that this is doing. Okay, so I push and hold the fluorescence button. That activates that. It makes the UV included measurement. Then it puts the UV cutoff filter in and makes the UV excluded measurement. And then it displays the fluorescent component. It displays this number right here. Okay, this was 7.6 for this sample right here. So we were getting a boost in brightness of 7.6 brightness units. All right, let's take this sample. I will load it on here. Its UV included brightness is 89.2. I'll touch and hold fluorescence. Now that filter is activated, it's making the measurement, and now my component reading is 4.3. So this sample does not have as much optical brightener as this sample has. It has about, about 60% of the OBA that this one has. Let's take a look at this. This is a pulp pad. Okay, so its base brightness is 79.5, and I do the fluorescence measurement, and the component value is 0. 0 because there are no optical brighteners present in this pulp. So again, depending upon how your dosage is, the instrument's going to read that differently. So again, the TAPPI method for evaluating the effect of optical brighteners is a pretty simple test, but a very important test to manage your optical brighteners. Now, we've talked earlier in this video about TAPPI and ISO, and a lot of the things are the same. But there are some differences between these when it comes to that. If you watch the ISO video, you will see some of those differences where this has some benefits of looking at different UV regions because of the pulse xenon flash lamp. But there are also some benefits to the TAPPI method that's important to understand as well, because they highlight things that you really have to pay attention to when you're using an ISO geometry. So as you guys know, the ISO geometry has a white coating on the inside of the sphere. So you have a lamp that sits here, it illuminates the sphere, and your sample sits here. So you're striking, or light is striking that sample from all angles, all right? But because that's a white high reflectance coating, one of the things that will happen over time, especially if you're in a moist or acidic environment, like a pulp lab, the coating will begin to degrade a little bit and yellow. And as that yellows, the first thing that it attacks and taking out is this region of the spectrum. So as that sphere yellows, you start to lose some of that UV energy in that. Now, if you're using a pulse xenon flash lamp, through the primary calibration of that instrument, it'll start pulling that trim filter out a bit more, so you can get more light into that. But at some point, it's going to be absorbing enough of that UV energy that it's not going to measure it accurately. So a part of of any good preventive maintenance program, part of our preventive maintenance program here at Technonite, is to do an evaluation of those spheres whenever we go in and look at them, or we service an instrument to make sure those spheres have not yellowed sufficiently that they're affecting this. Now, the benefit on this side is that there's no coating here. So a lot of our customers that are really have to be very particular about the control of their optical brighteners prefer to measure the effect of optical brighteners. They prefer to use the TAPPI method because it has one less variable that you can potentially have in an ISO instrument. So it's important to keep that in mind when you're making a decision as to which method do I want to use. Well, that could be very important for you to make a decision considering those things as well. Okay, so that's it. Like I said, it's not a big topic when it comes to how this guy measures fluorescence or optical brighteners on the brightness scale. Again, we'll get into more of things when it relates to color in the color video, but for right now, that's all we have on this one. Like always, if we've generated questions or if you'd like to discuss things further, don't hesitate to give us a call. These kinds of things are what we like to do. And so our goal, like we've always said, is our goal is to help you solve your problems. And at the end of the day,